All right. All right. Hello, everybody. Good for you to join us. So today we're going to be talking about Convex Desktop. So what is Convex Desktop? Convex Desktop is a desktop application that we've been developing alongside Convex to help people to access the Convex Protonet and mainnet when it's launched, but also as a toolkit for developers and power users to really get the most out of building and developing on Convex, and as a tool that actually anyone can use to access all the features of the Convex network. So it's quite an important tool, I think, in our arsenal. You don't need to use Convex Desktop. I mean, anyone can build a client or an app that talks to Convex. But Convex Desktop is a super quick way to get up and started, particularly if you're a developer or a power user and you want to really understand what the system can do, how it works, and actually try out some of the advanced capabilities. And personally, I use Convex Desktop all the time because it's a great way to develop. It's one of the reasons we developed it is because it is such a useful tool, and it gives us these capabilities, and it's getting better and better as we keep adding new features. So what I'm going to be doing today is going through the current version of Convex Desktop. I would say it is still in development, so we're still adding new features, and if any of you on the chat want to throw in suggestions or ideas about how we can make it better, then please do. I mean, the part of the purpose of these discussions is to come up with new ideas and to sort of build on the thinking and the state of the art of what we're doing here. So as always, we've got live chat. Anyone who wants to throw in a question, I'll be keeping an eye out and happy to comment or answer questions or discuss new ideas if people have got new ideas of what we can do with this. Start right at the basics. Hi guys, hi Nicholas, hi Rich, good to see you here. So start with the basics. Desktop app. So it is an app that runs on typically designed for running on PCs or laptops or Macs, where you actually download the app and use it directly. So you're not doing a web app. It's not in a browser. And it's also not a mobile app. It's not really designed to be run on mobile. So it's designed as like a regular desktop application. Now, let me go into a little bit about how this works. So I'm just going to switch over to my my demo screen. What I have here is in fact my development environment. This is the Eclipse environment that I use for building various tools and utilities in Convex, including Convex Desktop. So Convex Desktop is, for those of you who've looked at the code, it's in the Convex GUI module inside the Convex main repository, and there's a couple of different classes in here, but this main GUI is the new version of the desktop application. So I'm just going to run this and to see what we get. So I'm just going to run it as a Java application, and we're into Convex Desktop. So this is Convex Desktop. It has a brand new front end. So we've got this nice little visualization of the world, and I'm hoping that what we're actually going to be able to do is to get, assuming peers share this information, we'll be able to get points on the map marking where peers are located around the world. Obviously, if they don't want to share their coordinates, they don't have to do so, but any peer that does want to share their coordinates will actually appear on this map on the live network. So just a little bit of a fun visualization to see what's going on worldwide. And the desktop really has a number of different applications that sort of address different users and what you might want to do with it. So the most powerful button is this one here, which I'll demo in a minute. That's to launch a testnet. So you can use Convex GUI, the Convex Desktop, to launch an entire Convex network on your desktop in order to test things out. Very powerful. This is what developers might want to use if you're testing smart contracts or things like that. So that's the testnet launch capability, and we'll definitely go into this. Nicholas asks, "Is this done in Godot?" No, this is a Java application. It's actually done in Java with some cool user look and feel interfaces, And I think it actually looks quite good. Yeah, I mean, obviously happy to take ideas on how to improve the look and feel, but I think it looks quite nice, and it's snappy performance. Yeah, it's really good. We probably would use a game engine if we wanted to do a lot of 3D stuff or animations or things like that, but for Convex Desktop, it doesn't really need all the 3D stuff. So. And the other advantage, the other reason why we do it in Java is because the Convex core code itself is written in Java, and that gives us a special ability to actually run an embedded peer within Convex Desktop. So we've talked in some previous courses about how you can run peers in embedded mode. Convex Desktop actually lets you run embedded peers, which means you can work with them directly and access them directly and do all kinds of powerful things that you maybe couldn't easily do if you were doing it remotely. So why not Clojure? So good question. I find that Clojure is a little clunky for GUIs, and I find the refactoring in Java is pretty powerful and all of that. So I mean, your mileage may vary, but I actually quite like Swing as a GUI toolkit. It lets you do some quite powerful things, and often the Clojure stuff is really just a wrapper on top of Swing anyway. So implementation choice that I made, because I find it quite clean and simple. But that's probably because I've been using it for a while, and I know it pretty well. So certainly you could build a Clojure front end in a similar way if you wanted to. So I'll just go through the other options. We've got the terminal. I'll show this later, but basically the terminal lets you connect to any convex peer. So if you want to create a connection to a convex peer somewhere in the world, you can say what's the address of that peer, what is my address, my account address, and you can include your private key. If you want to be able to execute transactions, you need a private key. If I do that, of course, there's no peer running at the moment, but you can connect a peer to anywhere. So that will be really powerful if people want to work with Protonet and have all the power of the Convex Desktop tools, but working on a Protonet live instance. They'll be able to use that. We've then got the hacker tools. The hacker tools are some of the sort of the tools for developers, but quite useful tools that which I'll demo in a little bit. And then we have a couple of buttons just to help with people connect with the community. So let me just go to browser. If I click community Discord, it's going to take us to Discord, and if I click Convex World, it's going to take us to the Convex website. So just help so people can get some pointers and get to like documentation and useful things like that. So let's go through a bit what these things do and what you can do with this. So first of all, let's try launching a testnet. So we can launch a testnet, and it gives us basically two options. It gives us a number of peers, how many peers we want to run in our testnet. So in this case, I want to run 3. And you also get to give a Genesis key. So the Genesis key is the initialization key for the entire network. That is equivalent to what we would use to initialize Protonet as the sort of the master key to the network, which runs to set everything up, and most importantly sets up the first peer that runs, so that then other peers can be added after that. So it creates a random Genesis key by default. So if as long as you're happy with just a random Genesis key, then this will work sort of out of the box. So I'm just going to click OK, and we now have a running Convex network. So this says testnet peer manager here at the top, and we've got these 3 peers running. The little green lights show that they're all in sync and they're all processing some blocks. It shows their public key. It shows what port they're on. So this one's running on port 18888, which is the default port, and the other peers have just picked random ports. It tells you where the store is. So Convex uses the backend etch storage, and each of these peers has basically been given a temporary file for storage. So it'll just create a temporary file for the database while you're running your testnet. Once you shut your testnet down, they can just be deleted safely. It also says what state the peers have got, and how many connections they've got. In this case, the peers all have 2 connections because each peer is connected to all the other peers, but in some cases they might not be connected to everyone else. If I want to launch another peer, I can just click launch and it'll create an extra peer. So I've now got 4 peers in my network. Now these are all running locally, so they're running locally on my machine, but they are full peers. These are fully capable peers. They've got their own public key, they've got their own private key, and they've got their own engine processing in the background, handling transactions and things like that. So what can you do with your testnet? Well, probably the most important thing is I can click on any of these peer icons, and I get a REPL. So I get a window into the running peer, so I can see precisely what the I can interact with the peer directly. And this is, I mean, I've demoed this in a bunch of different examples, but this is where you can type in any Convex list code, and it'll execute that in the behalf of the peer accounts. Oh, great question. So why has the last peer got a different stake size? That is because when I launch a new peer, it allocates some of the remaining funds to the peer. Now there's less funds remaining when I launch additional peers. So if I launch another one, I think I get even less stake. Yeah, so this is now under 6. So because there's less and less stake remaining, it's going to have less stake available to give to the additional peers. So that's just a default setup. You can play with that in the code, how much it allocates to new peers. You can always go in later and change the peer stake. Yes, I want to peer stake. Let's drop the stake down to that. I'm going to forget the command. Is it set stake? Set peer stake. What's my address? This peer. Okay, so I've just destaked that peer. I think that's probably a reduction, and you can see now my peer stake has gone down to just 1 Convex gold. So that's not very much stake, but it's still on the network. It's still live. Once I've got these REPLs, I can execute any code I like. I can obviously change the stake like I've just done. All the stuff that we've demoed in previous times, you can do through these windows acting as that stairs. There's a bit of info. So this one shows some info about the peers. You can see like load averages, beliefs being sent and received. There's some like live statistics coming off the peer, and this is the advantage of running the peer in embedded mode. Yeah, you can access all of this live information from the peer, which is kind of useful. And there's it's running, etc. There's also a stress test tool. This is a little bit clunky, but what you can do with this is you can send a bunch of test transactions to the local peer network. See how many. I've got like 100 clients. It's doing 100 requests per client, 10 transactions per request. Let's distribute the requests over the different peers. See what happens. Okay, so it's just executed 100,000 transactions, getting about 55,000 TPS in 1.8 seconds. Yeah, so it's pretty cool. You can try out all kinds of different combinations of transactions and distributions of transactions and different types of transactions. I can probably do a null op and probably get more transactions. Yeah, I get like 100,000 transactions per second if I just do a super simple transaction. So that's useful for like just testing, performance and checking that your peers are behaving correctly under load. This kind of thing. How you could bring in a peer in the USA? Well, this particular testnet tool just runs peers locally. Yeah, but you could connect additional peers elsewhere in the world to this testnet, but you'd have to have open ports. and you'd have to set up the infrastructure so that the peers could talk to each other and give them public IP addresses and this kind of stuff. So it's a bit more complicated if you want to connect peers that aren't local, because you have to set up all the communications and all of that. The peers obviously support that, but I haven't got all of the network setups here. But that's the idea of this connect button, is you can start connecting peers elsewhere if they operate. Yeah, thanks, Riley. So nice little example. This is just running a test net, and that lets you have all of the capabilities you might want to develop on Convex. You can build smart contracts. You can create new actors. You can test out code. It even gives you a peer server REST API. So I can see the REST API set up with Swagger. So that's actually accessible locally as well. So if you want to do the REST development, that you can also do that using this little test net. Some other things that are quite handy. You get a little mini wallet. The wallet shows you your different addresses, how much balance you've got, what your public key is. So if you want people to pay you, that's obviously the key that you would share. Well, you share the address if you want people to pay you, but that's the key that you're using to prove who you are when you sign transactions. There's also, if you want, you can see your private seed. So that's my ED25519 private seed. It says warning, keep this private. Yeah, that probably should be blacked out until you press a button or something. So we probably need to do a couple of little. I mean, it doesn't really matter when you're running a local test net, but obviously for mainnet, we're going to want to make sure, and protonet, we're going to want to make sure that we're super careful with that number, because that number here is in fact the only thing you need to be able to control that account. So question, during protonet, all the peers will be up and running, and they could be in the USA, they could be anywhere. So you could run a peer anywhere. The only requirement is you've got a server that's capable of running a peer. So moderately spec server with decent amount of memory, decent disk, and a decent network connection is basically all you need. I mean, you see, I'm running 5 peers on my PC with absolutely no sweat. It is pretty lightweight. Although it does like a bit of memory, and it does like a bit of a decent network connection if there's a lot of transactions going through. But for protonet, it's probably going to be fine on a relatively low spec server. So that's the wallet feature. There's then this accounts feature. So the accounts feature actually lets you directly view all the accounts which exist in this test network. So there's like 240 odd accounts here at the moment. Some of the accounts have a balance, decent sized balance. They're like the sort of Genesis accounts and the sort of reserve accounts. You can see some actors. So these are some of the libraries and actors which are available on the network. Some of them have a memory allowance. Some of them have there's a bunch of user accounts. I think these are some of the ones these got created during the testing when we were running the stress test, so it creates some accounts just for testing purposes. So yeah, a bunch of user accounts. If it's a user account, you can also see their public key. So yeah, various little functions in there, which is kind of nice. And there's also some testnet stats, so you can see what have we got. We've got 5 peers, 243 accounts, 97 blocks so far. You can see the total amount of fees which have been accumulated. Total funds in the network is in fact always going to be, or should always be, this 10 to the power of 18, because that's the fixed maximum supply. Of course, most of that is unallocated at the start of protonet, so it's all just held back in reserve, but it still shows as part of the total. We probably should put an issued amount in here. In fact, I'll write that down, because I mean that's irrelevant, yeah. Because this isn't really the coin supply on the network. This is the max supply. So probably an interesting number for people to look at is what is the actual issued issued supply at any one time, and that's basically the total supply minus the amount which is still sitting in reserve accounts. So bunch of things about how many writes have gone to etch, etc., etc. So that's the peer manager. So you can run test networks. Just got working today. You could have 2 test networks running at the same time. So previously you couldn't do this. Previously you could only use one at a time, but now I can have 2 test networks running at once. So if I'm, doing some stuff and I want to have a fresh test network, that's pretty easy. And they've got their independent. They're running independent consensus, but they're still running a full test network. So yeah, double test networks running on the same machine, all works. So useful stuff. 1 gigabit internet should be fine. Yes, gigabit internet should be fine. We've designed certainly to work fine on gigabit internet. What is meant by stake? Stake here is the stake that the peers have got set. So in this case, total stake 206,000 Convex gold. So if I look at the peers, sorry, yeah, I think that's adding up to 206,000, just eyeballing it. So that's the total stake of all the peers on the network. So if you're a peer, you can obviously divide your stake by the total stake to see what sort of percentage you're running at in terms of total stake, and of course that's important because that determines the share of peer rewards that the peer would get. Okay, so you can shut down these networks. Just close the window. Let's have a look at a couple of the other things then. Oh, terminal. So terminal is terminal. I'll just launch another test network. Let's say I want to connect on the terminal, and I want to connect to this peer. So I've got it's account number 13, and I'll just get its. I'll just get its seed. So this is the ED25519 private seed, and let's double check. Yes, I've got 1888, so that's fine. So I'm going to do the terminal. I'm going to do localhost 1888. I'm going to put account number 13, and I'm going to put in my private key. If I run that, I get a REPL instance, and I'm in transact mode, which means that my key is probably correct. So if I run this, I can execute transactions. Now this is a client, so it's not directly connected to the peer. It's connecting using a remote network connection, even though it's a remote connection to my local machine in this case. So this is the standard REPL, so I can do query mode, I can do transact. So if I do query mode, you can see that my balance is not changing. If I do transact, you can see that a small amount of balance is disappearing from my account each time I run one of these. I can clear if I've got some junk on the screen. Now, some of the new features, people have used one of the previous versions of the interface. We've got a few new things. So one of the new things is I can see the full results. So before it would just show back the answer. Whenever I did a query, it would show you what the result of the calculation was, or the result of the query. If I go for full results and I do some operation, what it's going to do is come back with this record of data, which is like a more complete transaction receipt. So if you're familiar with Ethereum, this is the equivalent of a transaction receipt. So it has a bunch of information. It tells me the result in here. So the result of that sum was 6, and there was no error. But it also has this additional info record, which gives you some handy information. So it tells me that the fees were 2328. So 2328 convex coppers for running that transaction. The TX that's the transaction hash. So if you wanted to look up the transaction in the future, you could validate that using that transaction hash. It says how much juice did I use? I used 664 juice, and This thing lock is actually the location of the transaction. So this is block number 8 and transaction position 0 in block number 8 in the ordering. So if you wanted to go back into the consensus ordering and look for this transaction, you would find it at that position. So important for being able to audit and sort of double check on transactions and look things up in the future is to sort of record this location. Now, other results, I can also do I can show the timing. So if I do another transaction, it says how fast the transaction completed. So in this case, that transaction completed in 37 milliseconds. Obviously, because I'm running locally, there's not much internet delay, so that reduces the transaction time and consensus time, but you know, super fast. You're basically getting instant responses on this. But that's useful if you want to time how good response time is looking. You can connect to a remote network, or you can connect to Protonet, and you could say run your transaction and say, okay, that's taking 300 milliseconds, and then if you are doing a mobile app, that's the same kind of latency you would expect in the mobile app. Question: is juice equal to fees? Not quite. So juice is how much computation was done. Yeah. So juice is a measure of how much work was done by the transaction. Now, and fees is actually a combination of multiple things. One is the price cost of the transaction, so the cost of the juice. But then if you consume any memory, that's going to get charged as well. So you're going to get charged for any memory that was required. So if you have to buy memory from the memory pool, then that would get added to fees as well, although that wouldn't affect juice. And then there's like a base transaction. There's some base transaction fee, which is you pay regardless of how much execution you do. So let me show you something else. Actually, this is quite useful. Good question. I'll just turn off timing. But if I use this pre-compile option, what pre-compile does is before it sends the transaction, it compiles the transaction, and that saves you some of the juice cost, yeah, because you're not using the on-chain compiler. So you get charged if you use the on-chain compiler to compile your transaction. But if you're willing to compile the transaction yourself, or compile it in another way, then you can pre-compile the transaction, and you're going to get for the same transaction, I'm going to end up paying a lower juice cost. Or I should do. Why didn't that work? Oops. So I'm on pre-compile. I don't think they're pre-compiled. Double check. Yeah, okay, great. So here you see that without pre-compile, it cost me 664. With pre-compile, it only cost me 64. So I got a 10 times saving on juice, which is a decent amount. Yeah. So yeah, you can get quite a decent saving from pre-compile, and it's pretty safe. Yeah, as long as you compile correctly, it's going to execute and get you the same result. So there's some fixed cost in the fees, but basically the fees, I paid half or less than half for that transaction by doing a pre-compile. So you do save a bit of transaction fee from a pre-compile. So question: be nice if the formula from juice and memory to spate is transparent. So it is transparent. It's all defined in the CAD, the transaction cost CAD. So you can see the formulae and stuff. So there's a bunch of things, but there's a memory price. If you've got memory already, then it also uses your memory allowance first before charging you for memory. So you have to take into account a number of different factors. But yeah, the formula's fairly simple. It's basically your juice plus a base transaction cost multiplied by the juice cost plus the cost of any memory you consume. So if you consume any memory. So if I define something and I create something which uses define some data, and I'm going to compile this to be, set this to be some reasonably length string, I'm going to end up paying a higher transaction fee because it's going to charge me some memory as well. Actually, I didn't. Oh yeah. Okay. So it said yeah. So here it says I used an extra 64 bytes of memory by this, but it didn't really affect my fees much, and that's probably because I already have a memory allowance. So it just used my allowance rather than charging me any fees. But if I just take my allowance, sorry, memory. So my memory is like 9 million. So I've got some quite large memory allowance in this account. I'm not getting extra fees for memory in this case, but it would use up some of my memory allowance if I do defines. If I undefine that, undefine, what do I call it, data? Oh, I didn't get. I got allowance back. So again, I probably got allowance back from that. So my allowance has probably gone up. Yeah. See, so I got 64 bytes back by undefining. So that's 9913. This is 9977. So I got my 64 bytes of memory allowance back by undefining it. So. Also nice to pretty print the data structures. Yes, yeah, that's a good idea actually. Oh, it's a trade-off really. Pretty print means that these things become quite take up quite a lot of screen space. But yeah, we do have a pretty printer, so it's easy to do. But yeah, okay. So this is basically the transaction result reporting. So pretty important if you're trying to understand stuff. If I want to really just understand the juice of particular things, what I can do is I can do query mode, and I think, yeah. Yeah, okay, so if you really want to understand the juice of very specific instructions, yeah, so Nicholas is asking, nice to know what ops costs what juice. What I want to do is I want to do query mode, so I'm not getting any complexity for running in a transaction. I want to pre-compile, because I don't want to be paying for the compiler, because the compiler is going to be bigger than the cost of most operations. And then I just put in the operation that I want to do. So for example, a NOP uses 10 juice. A constant uses 5 juice. Maybe that's an oddity. Maybe a NOP should be cheaper than a constant. But yeah, it's definitely this is all defined in the juice setup on the Genesis. We do need to go through actually and review all the juice costs and just make sure that they're appropriate for the amount of cost that they have. You can see, like, for a more complicated thing, it's going to do, what's that, 51 juice for plus 1 and 2. Don't know where the 1 came from actually. What's plus? Sorry, plus. That's 5 because plus is considered a constant. What's 1? 5. 2 is 5. 25 with that. Plus 1. 38. Ah, yes. I think there's a juice cost for the size of parameter lists for certain operations. So the number of elements going into mathematical operations affects juice costs somewhat. So for example, if I add two very, very large numbers together, I think it costs more. Oops. yeah, it costs a bit more because I'm doing big numbers, so they're using more resources if you're computing with big integers. So juice does account for things like the size of some data structures or integers if you do things. I'm going to get that with like if I do this, as what that's juice 105. If I define a bigger string, is that the same? Surprised it's the same. Oh, that's probably because I pre-compiled it. Yeah, so just pre-compiling it. But let's do this. That's 154. That is 131. Yeah, again, so larger data structures are charging the charging bigger fees. Nice to implement some utility that breaks down your S expression into juice. Yeah, that's a good idea actually. You know what the actual juice component of each symbol or element is. I have to think a little bit about that, but it's definitely a good idea. It's actually an area that if someone wants to get it, if someone wants to get involved and contribute on the juice calculation logic, it's definitely an area that we could do with some review and validation that the juice costs are appropriate. Because the basic question is, why do we even have juice costs at all? Well, we have them because we want to charge a fair fee to people who execute transactions for the amount of computational resource that they consume, because obviously that computational resource is being provided across the network. So yeah, Nicholas, if you want to get involved and help us refine the juice costs and create some utilities to make sure that the juice costs are appropriate for different kinds of calculations, and absolutely that's a fantastic thing to have you involved with. So yeah, ping me on Discord and we can talk about how to do it, and I can show you where in the code that's set up, and we can maybe discuss some strategies about how to sort of validate it. So I mean, ideally we do some benchmarks and say, okay, well, how much computational resource is really getting used up by these? But it's obviously hard because as always, micro benchmarks are hard. You never quite know whether you're paying the true cost in a micro benchmark is not necessarily representative of the true cost in a large scale application. So there is a bit of how would you call it? A bit of judgment required in setting these things up right. So we're still going to, and one of the reasons we're doing the protonet phase before mainnet is so that we know that things like juice costs might need to be revised. Yeah, particularly if someone finds a denial of service attack, yeah, where they can consume a lot of computational resource for very little juice, then that will be a problem for sort of the security and integrity of the network. So we'd want to rebalance juice costs in that case to make it. We basically want a denial of service attacks to be prohibitively expensive, while making under normal conditions transactions cheap for users. That's basically the balance that we have to strike with things like juice costs. So okay, great. So yeah, and lots of fun you can have with the client. It's got a lot of new features, so a lot of recent improvements into making that happen. I just want to spend a bit of time now on the hacker tools. We haven't really talked about these yet, but the hacker tools, and we're probably going to add a few more of these. But there's two main tools at the moment that are particularly useful for people who are sort of hacking Convex and want to get into the nitty gritty. The first one is is the keygen tool. Now this is for your crypto keys. So what this does is it uses a couple of well-established standards in the crypto space to generate keys for Convex. Now I'll just show quickly how it works. What we're using is something called BIP39. And what that does is it creates this mnemonic phrase. So it's going to have currently 12 words, but you can change the number of words. If I'm super paranoid and want 24 words, I can have 24 words. It creates a bunch of words that represent some kind of random entropy, which is being used for key generation. And those words get converted into a BIP39 seed, which is kind of the root seed from the BIP39 standard. If I want to protect this with a passphrase, I can also add my own passphrase, which acts as an additional keyword, if you like, which makes it further obscures the seed and protects your keys. Every combination of words and every passphrase will give you valid keys. You know, there's an almost unlimited number of these things, and you can always generate as many as you like, and pretty quick to generate. Once you've got this BIP39 seed, we then have a process that turns it into the ED25519 seed, which is what Convex actually uses for signing transactions. So this private ED25519 seed is if you like your secret, which enables you to sign transactions, helps you gives you the private key for an account, and you also get a public key. So the public key is the key that you make public on the network, and is then used to validate any future transactions that you send in. One extra interesting point is we also now support these hierarchical deterministic wallets. So this is what's the standard called BIP32. You can give a path like this, and what that will do is create different ED25519 seeds from the same BIP39 seed. So if you've got a BIP39 seed, you can basically create this derivation path, and I think the most common standard is to use M/44. We would use we're actually in the process of applying for an official registered number, but it might end up being 696. And then you say my account number is account number 14, and it's address 0 is the fourth one conventionally, and I want my key number 78, and then that is then my seed for that particular derivation path. So this is a hierarchical deterministic wallet. So you have effectively almost infinite number of seeds can be generated out of this path. And if you have your BIP39 seed and you have your BIP32 path, you can always get back to your private key and your public key from this. So good little tool, fun to play with, and it is relatively secure. So it's using the secure random number capability on your machine to generate it, so none of this is going to the web or anywhere external. So if you were to do this on a laptop that wasn't connected to the internet anywhere, this will be a fairly secure method of key generation. Yeah. So obviously you don't want to do this on a machine that might have been hacked, but if you're a totally isolated air-gapped machine, this is relatively secure for key generation at least. So that's one of the tools. Nice little tool for key generation. And then we also have the encoding tool. So we've talked in previous calls a bit about the data lattice, about how Convex creates these data structures which can be shared and decentralized and easily transmitted over the network, and they're also used by Convex for execution in the CVM and for storing data and all of this. Well, the encoding tool basically lets you test out the binary encoding of any data structure. So if I introduce put in a data structure here, so this is just an empty map, so just the curly brackets. you can see that the encoding is 2 bytes long, its type is a map, its encoding size is 2, so there's 2 bytes. Its memory size is a technical thing, and while it's small enough and it's embedded, it's not going to get a memory size. And it's 1 cell worth of information, so there's actually just 1 single cell in this tree of data. If I make a bigger data structure, let's put in some text, you can see, okay, it's still a map, but now the encoding size is 44 bytes and the cell count is 3. So you've got 3 cells. Presumably that's the map itself, the keyword that says data, and the string which has this data inside. And you know, if I put some more elements in the map, you can see I'm getting more bytes and more cells. So it's quite useful if you want to really validate how any particular data is getting represented. And you can also work both ways, so I can actually edit the representation. So if I change this, so I've got a 2 at the end here, I should be able to just delete that. That's invalid, but now I've just made that into a 3 by altering the byte representation of this data structure. I should be able to change some of the text as well. Where's it? Data. So we're going to change the D. So 82 is the map. 2 is the number of map entries. So 33 is the keyword. 4 is the number of bytes in the keyboard. So if I wanted to change it to kata, that's presumably 63. Yeah, kata. Yeah. So you can actually see how changing the binary encoding what data structure that comes up with. And for every one of these, you also get a hash. So the hash here should also change whenever I update this. So I get a completely different hash for any different encoding, which is what gives us the security and the integrity of all the Merkle trees that represent this data structure. So pretty useful tool. This doesn't look very meaningful to humans, but this is actually what gets sent over the network or stored on disk when any convex data structures get transmitted. So useful for debugging, useful for sort of understanding how the data structures work. If I enter something which is invalid, it's going to tell me message decoding failed, or some error. And it'll tell me why it failed in this case. So it's saying unrecognized tag byte 56. If anyone can get this to crash, by the way, there's free Convex coins for finding a bug in the encoding decoder. So basically, I should always either get a failure or I should get something valid. So yeah, 10 is the number 0. Excess bytes, so excess bytes should call a failure. So if I put any excess bytes on the end of something which is valid, it should be a failure. So there's a bunch of things you can try out. So getting the encoding working is pretty important, because one of the reasons Convex can be so fast is because it's got this very efficient coding format, which means that data structures are getting coded in just a few bytes, and the hashing is happening usually at a higher level, so multiple data structures are getting hashed at once. And that's what means that our Merkle trees are so fast, and it means that the network bandwidth can be minimized and the storage can be minimized and all of these kind of things. So nice tool if you're playing with the inner workings of the network and the encodings. So that's Hacker Tools. We'll probably be adding a few more things to that. One of the things I would like to add is a tool that lets you pre-construct and inspect transactions. So let's say you had a particularly high value transaction. You might want to pre-construct that transaction and check that everything is correct. yeah, and validate that the transaction does what you expect it to do before you sign it and before you send it on the network. So that's another quite important tool for both for testing purposes, but also for security purposes. If you're doing high value transactions and you want to verify things independently, rather than just firing off requests and not knowing what's happening. So that kind of thing is a part of the toolkit that we want to make available. Other things I'd like to do is have better tools for importing keys. Yeah, so be able to import keys from different formats, different kinds of key stores, these kind of things, so that you've got different backup options, this kind of stuff. So anyone who's heavily into their crypto will know the importance of good key security, and this is and giving people good tools is part of that. Question: are the tools already on the website? So these tools they're all part of the desktop app. We will be providing a version of the desktop app alongside Protonet. Right now, you can get the development version of the desktop app. I'll share it on Discord if anyone wants to have a play with it. But if anyone wants to actually build it and actually hack on the desktop app, what happens? Well, so I've got Convex GUI. I'm going to run this as a. Probably need to shut this down. Shut that down just in case. I run as Maven install. And this is basically doing the Maven build of the desktop app. So it runs through a few tests. It checks a bunch of configurations, build success. So it's built Convex Desktop, and if I go into the target directory, you'll see I've got a convex desktop.jar file. Let me just drag that onto my desktop. So it's just one file, convex desktop.jar. So we can give that to people to download. If you double click it, you're back in Convex Desktop. Yeah, so it's a runnable jar file. Now the only thing I would say is it needs people to have Java set up on their machine, otherwise it won't run. But as long as they've got Java, it should be absolutely fine. So yeah, I'll send this file around on the Discord if people want to play with this version. But I say if you want to build your own, it's just Maven install on the Convex repo, and you will get Convex Desktop in the Convex GUI target folder here. So it's pretty easy and it's pretty lightweight. I mean, I think it's only it's less than 40 megabytes, so it's not a very heavyweight application. And actually, that's pretty cool because it's not only it's a desktop app, it bundles inside it all of the Convex core code, including the peer implementation, including the networking code, including the crypto key generation code. So it's basically pretty much everything in Convex is less than 40 megabytes at the moment, and that includes stuff like images and graphics that make the desktop look pretty, which probably use up more space than anything else. So yeah, it's pretty lean. It doesn't need a particularly beefy computer to run. So I'm quite pleased with how it's going so far, and I think it's starting to look quite nice and have quite a lot of useful tools. So yeah, hopefully people find it useful. I mean, I certainly use it all the time. If I'm developing apps that work with Convex, I would just typically fire up one of these test nets and just have a test net running in the background. So I can deploy smart contracts, I can test things out. If I ever want to go and see what's happening directly, I can always go straight into a REPL and execute transactions directly, hack some code, whatever makes sense. So it enables this, and I think this is very important, it enables this sort of live interactive experience with the network. Yeah, we want our tools to be very interactive, be very hands-on, and to let people really touch and feel what's going on. So that's really the important thing about Convex Desktop, is it's putting that sort of power in people's hands in a sort of convenient form that they can use on their home computer. So you can potentially, Nicholas asked a good question. Could you make native images using GraalVM? Yes, you probably could. I'm just trying to think if there's anything that might upset GraalVM. I think it's probably GraalVM compliant. I've not tried, but yes, you probably can build native images. The problem with native images, and this is my rant about this stuff, is you end up having to build multiple of them for different people. Yes, you can build native images, but then people have got to make sure they get the right one. And the nice thing about a runnable jar file is yes, you need Java installed, but probably any serious developer probably has it already, and it's the same file, so you've not got to mess around with versions and different incompatibilities with different native platforms, etc., etc. So that's the reason we've kept it as a runnable jar so far. But yeah, if people really want to get native images, we can, you can certainly build them. I'd have thought. I think it would work with GraalVM. For those who don't know, GraalVM is this very clever piece of compiler technology that takes JVM code and turns it into native binaries. But I mean, honestly, most people use GraalVM because they're worried about startup speed, and that is not a long startup speed for a desktop application. Yeah, it is not slow. And it's not like you're launching it hundreds of times at the command line. You're going to launch it once, and then you're going to create your test net, and you might have this open for like 3 days while you're doing a bunch of developments. So I don't think the startup time benefit of GraalVM actually wins you much in this case. So your mileage may vary, but I find the runnable jars generally fine. Yeah, of course. Yeah, we can. Look, if anyone wants to do it, then please do. Yeah. So if someone wants to make a user-friendly installer and make that available on the website, then yeah, please do it. Yeah. So it's definitely something that if someone in the community wants to do, we can definitely support that. Yeah, I mean, I get the user-friendliness point. I mean, but you still have to install a binary somewhere. You still have to click through some things. We could probably make an installer that installs Java as well as the desktop app itself. That's another option. I mean, I've seen a bunch of different solutions to this. So it is a power user tool. I would say it is not a tool that's designed for your grandma to do their first crypto. Yeah. Now, I do want to add a simple coin wallet. That's another piece of this which is missing. And again, this is absolutely a great thing for contributors to get involved and help hack on. If people want to hack on this, then I'm very happy to sort of get people involved in this, because I mean, I quite like building GUIs, but it's nice because it's a fairly simple way to get hooked into how working with Convex at the sort of core level. Yeah. So I mean, you got some code and you want to execute a transaction, and then figuring out how that works and how you link that up with the GUI and building the user interface is quite a good way to get on top of that kind of stuff. And it shouldn't be that hard to build a simple multi-coin wallet. So have a wallet that lets you have Convex coins, lets you send and receive, and then fungible tokens. So send and receive, and maybe swap on Taurus fungible tokens. Doesn't have to be particularly sophisticated, but we probably should have a sort of user-friendly wallet as part of the desktop app. Because I mean, of course, you can do it. You can all it will be doing is giving a nice front end to instructions like this. Yeah, that's all it's going to do when you do a convex coin transfer. But the building a GUI that just makes that easy for people, and checks that you've sent the right transaction and confirms it all gone through correctly, etc. That kind of stuff is probably nice to have. So again, there's a few things like that. So there's a user-friendly coin wallet. There is possibly native bundling if people want to play around with native bundling. Possibly key management, so better ways of managing keys. I'm sure there's a bunch of other tools. Markets. So we haven't even talked about markets yet, but it does have a link to Taurus. Doesn't do much yet, but I don't think that works yet. But it does say what are the current tokens listed on Taurus. So in this case, I've got 2 tokens and some amount in the liquidity pools. There's an amount of a token and an amount of convex coins, and there's a price ratio between these 2 coins. So it knows about Taurus. It knows Taurus exists. But we could have a better Taurus interface with like charts of prices and stuff like that. So and some trading analysis, and placing buying and sell trades and stuff like that. So there's a bunch of interesting things that could be added to the desktop app. As I say, it's all open source as always, and contributions and people getting involved with hacking on this is always super welcome. Okay, well, I think we've sort of come to the end of the hour, but thank you very much everyone for joining and for some great questions and some great ideas, which will definitely be resulting in some more improvements in Convex Desktop in the near future. And as always, chat on the Discord if you want to get involved with building any of this. Then let us know, and we can have a more in-depth discussion. And hope you've enjoyed it, and look forward to seeing you all next time. Bye for now.